Okay, so today we're going to look at the derivative of y equals log base b of x. And again, let's figure out kind of where this comes from and what its derivative might be by using the example y equals log base 2 of x. So I'm going to rewrite this as an exponent. So I'm going to write 2 to the y equals x. Well, I already know how to take the derivative of 2 to the y. It's the same thing as taking the derivative of b to the x. So if you refer back to your notes, you can see how to do that. But it's in terms of y. So remember, when it's in terms of y, we write dy by dx. Well, dy by dx of this is 2 to the y ln 2. And the derivative of x is just 1. So again, I want to solve for dy by dx. So dy by dx is equal to 1 over 2 to the y ln 2. Well, if I refer back to, well, what is 2 to the y? Because I would really like it in terms of x. Well, 2 to the y is just x. So I have dy by dx is equal to 1 over x ln 2. So if we're going to put this into a general form, well, now it's just base b. So I can say the derivative is 1 over x ln b. Well, let's look at some examples to see how this might work. So I have log base 7 of x. So its derivative just actually follows straight from the rule. So dy by dx is equal to 1 over x ln 7. Okay, if we want to apply a little more challenge to it, let's look at something like this. So log base 8 of 3x squared plus 2x minus 5. Well, let's refer back to the chain rule, where g of x is log base 8 of x, and h of x is equal to the polynomial. Well, if I want to take the derivative of g, I know it's 1 over x ln 8, and the derivative of the polynomial is equal to 6x plus 2. Let's plug these into the chain rule. So dy by dx is equal to h prime times g prime h of x. And I can simplify that. I'm going to factor that at the same time just to see if maybe there's something that might cancel out. So I'm going to factor out a 2, and I'm left with 3x plus 1. And this is all over 3x squared plus 2x minus 5 over ln 8. I can check to see if this polynomial factors. So I'm going to check to see. So we have minus 15. So we're looking for two numbers that might add to 2 and multiply out to minus 15. Well, I can check 5 and 3. So 5 and 3 do work. So I can actually factor this bottom. So if you go ahead and factor it, and then we'll put in the answer. Okay, so we can simplify that further to 2 times 3x plus 1, and we get 3x plus 5 and x minus 1 ln 8. So nothing further cancels out, but it's always good to check. Okay, and if you're interested, this is what the factoring looks like. Okay, so two numbers that added, so we got 5 and 3. We factored out an x, we factored out a -1, and that's what our two brackets would look like. Okay, if we look at one like this, we're going to have g of x is equal to log base 2 of x, and h of x is equal to 4x minus 5, all to the power of 7. So then g prime of x is equal to 1 over x ln 2, and h prime of x is equal to 7 times 4x minus 5 to the power of 6 times 4. That gives me 28 4x minus 5, all to the power of 6. If I put those all together, I get dy by dx is equal to h prime times g prime h of x. Well, I can simplify that. I can easily see that there are 6 4x minus 5s, and there are 7 of these. So I'm going to cancel these out and simplify, and I'm going to cancel all of those out. So I'm left with 28 all over 4x minus 5 ln 2. As you can see, again, another pattern is starting to emerge with the more examples that we do. So let's look at a shortcut. So if the original function is f of x equals to log base b of some function a of x, then its derivative, f prime of x, is equal to a prime of x all over ax ln b. And you can go through and check to see that that works. Okay, let's go through two more examples and see if we can put this together now. Okay, let's look at example D, where we have log base 21 and then we have a quotient. I don't really want to use it like that, so I'm actually going to rewrite this using some log rules. So I'm going to do log base 21 of 4x minus 7, and I'm going to subtract log base 21 5 minus 3x. Well, I'm going to do the derivative of this minus the derivative of that, and I'm going to use the shortcut that I've just learned. So I can say the derivative dy by dx is equal to the derivative of this, which is 4, all over 4x minus 7 ln 21. And I'm going to subtract the derivative of this, which is minus 3, all over 5 minus 3x ln of 21. Well, I want to put those together now, so I'm going to find a common denominator. So I have 4 times 5 minus 3x. I'm going to add 3 times 4x minus 7. And this comes all over the denominator, 4x minus 7, 5 minus 3x, ln 21. I want to neaten it up a little bit, so I'm going to multiply the top out. So I'm going to get 20 minus 12x plus 12x minus 21 all over 4x minus 7, 5 minus 3x, ln 21. And I can see this simplifies nicely, as these will cancel out. And I'm left with minus 1 all over the denominator. last example, this we're going to use the product rule. So I can say that a of x is equal to 5x to the power 4, and I can say that b of x is equal to log base 5 x squared. Well, the derivative of a of x is a prime, and I get 20x to the power 3. The derivative of b of x, b prime, is the derivative of this, which is 2x, all over x squared ln 5. And I can simplify this to 2 over x ln 5. So now I'm going to apply the product rule. So I can say that dy by dx is equal to 20x cubed log base 5x squared. And we're going to add 5x4 times 2 over x ln 5. Well, about the only thing I can reduce is right here. So I can reduce this to a 3, and this is gone. And I'm going to neaten it up to 20x cubed log base 5x squared plus 10x cubed all over ln 5. And I'm going to do some factoring and also putting it all together. So I want this over the same denominator, so I'm going to add in a ln 5 here. And I can put it all over the same denominator of ln 5. And now I can factor out a 10x cubed. And I'm left with 2 log base 5 x squared times ln 5 plus 1. And this is all over ln 5. So you can see sometimes they do get a little bit messy and a little bit long, but you can still work through it. The end.